Hello everybody. This video is an introduction of ANCOVA, Analysis of Covariance. ANCOVA stands for Analysis of Covariance. The analysis of covariance was first developed by R.A. Fisher, and the very first example of its use appeared in literature in 1932. To understand how an ANCOVA works, we should understand the ANOVA. An ANOVA, analysis of variance, is used to determine whether or not there is a statistically significant difference between the means of three or more independent groups. For example, suppose we want to know whether or not studying technique has an impact on exam scores for a class of students. We randomly split the class into three groups. Each group uses a different studying technique for 1 month to prepare for an exam. At the end of the month, all of the students take the same exam. To find out if studying technique impacts exam scores, we can conduct a one-way ANOVA, which will tell us if there is a statistically significant difference between the mean scores of the three groups. An ANCOVA is an extension of an ANOVA in which we would like to determine if there is a statistically significant difference between three or more independent groups after accounting for one or more covariates. A covariate is a continuous variable that covaries with the response variable. Assumptions of ANOVA. Before performing an ANCOVA, it's important to make sure the following assumptions are met. The first one is the covariates and the factor variables are independent. The covariate and the factor variable should be independent of each other, since adding a covariate term into the model only makes sense if the covariate and the factor variable act independently on the response variable. The covariates are continuous data. The covariates should be continuous, that is either interval or ratio data. Homogeneity of variances. The variances among the groups should be roughly equal. Independence. The observations in each group should be independent. Normality. The data should be roughly normally distributed in each group. No extreme outliers. There should be no extreme outliers in any of the groups that could significantly affect the results of ANCOVA. For example, a teacher wants to know if three different studying techniques have an impact on exam scores, but she wants to account for the current grade that the student already has in the class. She will perform an ANCOVA using the following variables: factor variable studying technique, covariate current grade, response variable exam score. Tabachnik and Fidel in 2013 review three general applications for an analysis of covariance. It includes increasing the power of the F-test in experimental designs, which means participants are assigned to treatment and control group in an ANOVA based design. ANCOVA can then be used as a means to eliminate unwanted variance on the dependent variable. Equating non-equivalent groups, that is the second general application. By using the ANCOVA, it will correct initial group differences that exist on the dependent variable. And the third application is adjustment of means of multiple dependent variables. This application is similar to the ones outlined above, but when the researcher is measuring multiple dependent variables such as multivariate ANOVA or MANOVA. Thank you for listening to this video. Thank you.